Welcome again to our tutorial video on complex number with more examples. So technically, for those that have not watched the previous video on complex number, like we said, now complex number help us to solve equation that are of the form, equations that are of the form x squared plus 1 is equal to 0, which we said this equation will lead us to have x squared is equal to -1, right? So you end up trying to take the square root of -1, right? So technically, that's what we're going to be discussing today, how we can express the complex number in terms of the real numbers. Good. Now, before now, we have talked about the quadratic function, which generally is of the form x squared plus bx plus c is equal to 0. Then we have the general formula to obtain the value of x. In this expression, the value of x, you can always get it as minus b plus or minus the square root of b squared minus 4ac, right? This is all over 2a. Good. Now, this is known as the quadratic formula, right? This is the quadratic formula. Good. And sometimes called the almighty formula. Now, basically, if the value of all the elements under the square root sign, if it is possible, so positive, that's b squared minus 4ac. If this is greater than 0, which means it's positive, now we can solve this. Now, if this particular value is less than 0, now the value will become negative. The value under the square root sign will become negative, and that is when we are going to be using the concept of complex number. Now, if you recall, we say that the complex number, right, is of the form a plus bi. This is the real number, and this part is what we call the imaginary part. This is imaginary, right? Imaginary, while this is the real part of this is the real part. Now you can always see it also as x plus yi, or you can see it as z, right, which is just a plus ib, or x plus yi. Always remember, this is the imaginary part and this is the real part. This is the imaginary part and this part is the real part. Now, also what you are supposed to understand is that we have also understand that the I which you have here is just the same thing as the square root of -1. Good. So that's what we have discussed in the previous class, and then we're going to be taking some examples right now to solve some more practical examples, and how maybe if we have time, we can always review more examples. Now, two particular complex number, for example, a plus bi. Now, we say that this particular complex number is equal to c plus di if these conditions are met. Right? So that means if A is equal to C, subsequently, if B is equal to D, right? Now, this is called comparing the real and the imaginary part of the complex number. If this particular part of the complex number is equal to this part, and then this part of the complex number here, if it is equal to this part, then you can say these two complex number are equal, right? So we also talk about some few problems which we dealt with. So today, basic operations, right? I'm going to be doing the general form. In the previous video, we have taken some more examples. For this is the general form of this particular complex number. So if you have complex number a plus bi, right? If this is supposed to be added to another complex number c plus di, now generally what you're supposed to be doing is you're adding the real part together, which is a plus c, right? Then we're adding the complex, the imaginary part together. Now this is going to be plus, right? B, then plus D, right? Then this particular operation here is done for the imaginary part. This is for the real part. Now, subsequently also, let me give a general knowledge. If you have x plus y, I minus, you now have, say you have a plus bi, just introducing another complex number. So here is going to be x minus a, right? Then minus into, you now have y minus b. This is the imaginary part, right? So you can see it's straightforward. Now, remember, when we talk about I here, is equal to what? Square root of -1. So if I decide to take the square root of both sides, I squared, and I decide to take the square, right, this is 1. So if I decide to square both sides, technically, so what am I going to get? I'm going to get square root of -1 all squared. Now from our simple algebra and indices, this is going to be what? Just -1. So technically, -1 is the same thing as I squared, basically, because this will be able to allow you multiply complex number. So if I want to multiply complex number, so let's say we have a plus bi. Instead of adding, I'm supposed to multiply it with c plus di, right? So technically, this is going to give me AC because I'm taking this, multiplying this, right? This is AC. Now, also, I can now take the second part to multiply the other one. I'm going to have plus what? BI. This is BI multiplying DI. Now, this is going to be what? BD, right? Now this I'm going to get I squared. Let me just write it I squared. So I've taken this one to multiply this one, right? So I'm taking, let me take the blue to multiply the other element, which is A multiplying this guy. So this one will now have A, D, and I. So if I'm taking, let me take another color over here to multiply this other guy, B here, with what? With this guy over here. So we're going to have plus, then we'll have B, C, and I, right? So technically, you're supposed to take this element, multiply this element, this same element, multiply this element. Then if you're done, you pick this element multiplying this element over here. Then you take the same element and multiply this element, which is here. So the same thing here. If I'm going to take this particular element here, over here, this is I squared, right? And we say I squared is the same thing as -1. So automatically here, I'm going to have in AC. Then instead of I squared, I can replace it with -1. So -1 multiplying everything here, this is minus BD, right? So here, technically, I can just say I have AD plus BC, then all this is just I, right? So technically, this is what I'm going to be having at the end of the day. Now, also, if I want to divide a complex number, right? If I want to divide a complex number, let's give some example here. If I have let's say I have A plus BI. Now I'm supposed to divide this by C plus DI, right? Now, basically, this is very, very interesting because from what we have discussed before, from the concept of conjugate number, conjugate of a complex number, conjugate. If you remember, the conjugate of a complex number is just that same number with the sign interchange. So, for example, if I have give me like x plus yi, then the conjugate of this is just going to be x minus yi, right? And we know if you multiply any complex number by its conjugate, right, we're going to be having the real part of that particular complex number, which we have discussed before. So if I'm supposed to divide this, right, all I need to do is to just take the conjugate of the denominator and then multiply this particular expression. I'm going to take the conjugate of this denominator and then multiply it by that particular fraction. Now, what have I done? You can see that C minus DI upon C minus DI is technically equal to 1, right? If I cancel out, it's going to be equal to 1. But now what I'm trying to do is to multiply it by everything over here, because I know that the denominator is going to be having only the real part at the end of the day, right? So let's multiply this together. So what I'm going to get, if I use the expression that we already have earlier, right? I'm going to get A plus AC, right? This one and this one. Let me just conclude with what we have here. So I'm going to have AC, which is here, right? Then for the other part, BD. So BD, I'm supposed to get minus. So technically, we're talking about the complex number before now. So the complex number is very unique. So we are going to be continuing from the previous video, which is we have done addition, multiplication, subtraction. Then the division, we say that we are going to be doing is like this: A plus BI when you divide it by C plus DI. So we say that you're going to be multiplying both sides by the conjugate. You can watch the previous video to know more about conjugate. But conjugate is very simple. Let me put it over here. The conjugate of a number, if z is a complex number and is x plus iy, or in some textbook, you're going to be seeing it as x plus yi. Then the conjugate of this is going to be z asterisk, or in some textbook, you can see it as z bar. This is the conjugate. Then this is just going to be x minus yi. So technically here, we're going to be multiplying it by c minus di, which is the conjugate of the denominator, c minus di. So this is going to be giving us, let's multiply it together. We're going to be having AC, right? So let's multiply this and this. This and this is going to give us minus BD, then I squared. And we can recall that I squared is equal to minus 1. So we have BD I squared instead of the negative here. Since we have minus 1 multiplying BD, then we're going to be having plus 1, right? Good. So the denominator here is going to be, let's try and get what the denominator is going to be, c squared, then this and this is going to give minus CDI, this and this is going to give us plus CDI, then this and this is going to give us what? Now it's going to give us minus DI squared. I squared is minus 1, so this is plus CDI. So we're going to be having c squared plus d squared. Technically, the other part also is going to be having the same denominator because that is the common denominator for the both sides. Then the other element is going to be b multiplied by c, which we have done before. Then this multiplied by this is going to be giving us minus a, and then d is going to be giving us minus. It's going to be give us minus AD, right? So it's minus AD. Good. So this is what we're going to be having at the end of the day. But basically, we're going to be moving straight to some examples. So let's see if we have 1 plus 2i. And this is supposed to multiply 3 minus I. So basically, we're going to be having 1 multiplied by 3, right? 1 multiplied by 3, then we have plus 1 multiplied by minus I, right? We're done with 1. Let's take out this one. We're going to be having plus 2i multiplied by 3. Then lastly, we're going to be having plus 2i multiplied by minus I. So this is simple. We're going to have 3 here. Here we're going to have minus I. Here we're going to have in plus 6i. Then here we're going to be having 2, negative 2. 2 multiplied by this negative 2. Then we'll have I squared. I squared is negative 1, right? I squared is negative 1. So here's going to be positive 2. So we're going to be left with 3 plus 2, which is 5. Then we have minus I plus 6i. Then this is minus 5i. So I think it's straightforward. Then you can do this for other examples. Good. Now we have a very fantastic example over here. Now, there's a problem. It says find all those z. So we're talking about find all those complex number that satisfy this particular equation, that satisfy z squared is equal to I. Now find all the numbers where possible where this is satisfied. Now we have a technical problem over here, right? So how can you be able to solve this particular kind of problem? Now you recall that for every complex number, we can always write this complex number z in the form of what? A plus bi. Why? This is technically a is the real part, while the other part, which is bi, is the imaginary part, right? So if we want to solve that particular equation, what are we going to be doing? We're going to be looking for every possible cases to solve for z squared to give us I. So technically we have, if this is what we have, then z squared is going to be what? A plus bi all squared, right? So if we square this, what are we going to be having? Now we expand this, we're going to be having a squared plus 2abi, right? Then we're going to be having plus bi also all squared. So at the end of the day, we're going to be having a squared plus 2abi. Then I squared is technically minus 1. So we're going to be having minus b squared, because I remember I squared is minus 1. So our z squared is just going to be a squared minus b squared, then plus 2abi. Good. Now, since we can equate the real part and the imaginary part of our particular equation, this is the real part and this is the imaginary part, and we know that this is equal to I from this particular expression over here. So we can equate the real part and the imaginary part together. So we are going to be having a squared minus b squared. We don't have any real part over here, so this is just going to be 0. While here, we are going to be having, for the second one, 2ab is going to be equal to 1 over here. Technically, it's going to be equal to 1. Good. So this is for the real part of this particular equation. This is for the real part, and this is for the what? For the imaginary part. This is the imaginary part. So from here, we can have a squared. This is equal to b squared. So we can have b to be equal to plus or minus a over here, right? So so the next step we're going to be doing is to solve the imaginary part of this particular equation, right? So how can we do that? We have b to be equal to plus or minus a squared. So we can substitute a for b and also substitute b for a in this particular equation over here. So if we take, for the first part of the equation, if we take b to be equal to a here, what we're going to be having here will be 2a. Instead of b, I still substitute a, will be equal to what? 1. So technically, I have a squared is equal to 1 all over 2, or I can say that a is the same thing as the square root of 1 all over 2, which is the same thing as 1 upon root 2, right? Now, in the same manner, if I put b